Welcome to another coding tutorial, and in today's video I'm going to show you how to make this oscillating circular wave pattern. If you like this sketch, I also recommend that you check out this video that I did a few months ago as a collaboration with Daniel Schiffman of the Coding Train. In this sketch, I did a very similar thing but with a different approach, and I also integrated it with the face mesh model from the ML5 library. We're going to start by figuring out how to create the oscillating motion. So I'm going to start by declaring a few variables. The first one is called pose for position of the moving or the oscillating ball. And then the second one is going to be called center. And I'm going to create these positions inside a vector object. And a vector object can hold 2 to 3 values. And I'm going to use it to hold the x and y coordinates of the position and the center. And I can create a vector using a method called createVector, and we just need to provide the location, the x and y location. So for the position, I'm going to just put it at 100 by 100 pixels. And then for center, it is going to be at width divided by 2 and then height divided by 2. And then why don't we just create 2 ellipses at these 2 locations? So let's use the ellipse function. Then how we extract the x and y locations inside a vector, we just need to do the name of that vector dot x and then dot y. Let's give it a size of 10. We're going to do the same thing for the center. So center x, center y, 10 by 10. Oops, ellipse. All right, so now we have this pose vector and then the center vector. Now I want to find the direction between these 2 vectors, and I can do that by subtracting 2 vectors, and it is going to give us the direction and magnitude between 2 vectors. Why don't we declare a new variable called dir for direction? And to subtract 2 vectors and get a new vector, we can use a method called p5.vector.sub, and we need to provide 2 arguments, which are the 2 vectors, and the position at which we put in here matters. So if we want a vector that points from the position vector to the center vector, we need to put in center first and then position next. Now what I want to do is that I want to draw a line that actually represents this direction. So what we need is a line function, and I want to draw it from this point, which is pose.x and pose.y, right? And I want to draw it from here to here. So we could do this center.x and center.y, but basically it is also pose.x plus dir.x, right? And then pose.y plus dir.y. Run. All right. And just to show you that actually it is going from the point here, position vector, to this point, I can just divide direction by 2. And then you can see that it goes from this point to that point. So basically now we can give the direction vector a different magnitude, right? And so this is actually just going to change the length of this line. But basically we don't want to actually just change the length. We actually want to move this point here, position, back and forth. To get the oscillating motion, basically we need to use either a sine or a cosine function and provide an angle that we vary over time. And the sine or the cosine function oscillates between value of -1 and 1. So basically what we want to do is that we want to multiply that with a certain magnitude, and that magnitude actually is going to be the magnitude between these 2 points. So it's going to be the magnitude of the direction vector. So why don't we calculate that first? I'm actually going to call it maximum magnitude. So max mag, and to get a magnitude of a vector, all we need to do is just call that vector dot mag. To get the oscillating motion, I'm going to declare another variable inside the draw loop here called oscillation and set it to a sine function. You can do a cosine function too, that it's just going to give a different starting point. And then we're going to provide angle as a variable, which I'm going to start at 0. And then, like I said, this is going to vary between values of -1 and 1. And so we need to multiply it with a certain magnitude to get a different amplitude, right? So that magnitude is going to be max mag. And then now the oscillation variable here just gives us a value between negative maximum magnitude and positive maximum magnitude. So we also want a new vector that is going to give us a direction that this ball should be oscillating. So I'm going to actually call it oscillation dir for oscillation direction. And we want to get a new vector that is based on the direction that we have here, right? dir and the magnitude here. So we can actually do that using a method called p5.vector.setMag and provide two variables. The first one is the direction that we want. So it is this vector, and then we're going to multiply it with this magnitude here. So oscillation, it is going to set this new oscillating direction that is going to go back and forth between these 2 points at a magnitude of this oscillation variable here. Now what we need to do is that we need to basically set a new position, right? We have post vector here, but the new location has to be added between the post vector and the oscillation direction vector, right? We can create a new vector called new post, and it is going to be a new vector that is made up from adding two vectors, the post vector and the oscillation direction vector. So we can do p5.vector.add, and we're adding post and oscillation dir. So it's basically this, right? But because the direction is constant. So now what we need is we need to change this to new post. Actually, I'm just going to keep it as post for now, and how about we change this part to new post.x, new post.y, and it's just going to move the line. Oh, and we need to also increment the angle, right? So how about we increment it by 0.1. All right, so just going back and forth. And if I were to actually change the location of the post vector here, so you can see that the closer it is to the center, the smaller the maximum magnitude, right? Which makes sense because it's closer to the center. The magnitude is now smaller. All right. Then now, instead of drawing a line here, why don't we do new post.x and new post.y here? And then now it is the circle that is moving back and forth in an oscillating motion. All right, so now we're going to put all of this inside a class. And so what we need to do is we need to come to this arrow here, click the plus sign, and then click create file. How about we call it dot.js, add file. Now we need to also reference the file. So let's go to index.html, and then let's copy this line of code, change the name here to the name of your new file. In my case, it's dot.js. All right, so inside dot.js, we're going to start with the word class called dot, and inside the constructor function, what we need is we basically need all of this and also angle. I'll come back for that. All right, so we need to make sure we do this dot for all of this. And instead of hard coding the number 150 by 150, I'm going to give it x and y, and these are going to be the parameters. Next, we also need angle, right? We can delete all of this. And actually, instead of setting it to 0, I'm going to make it a parameter as well. And then I'm going to write two additional methods called update and display. And we're going to put all of this code inside. All right. Then change all of this to this dot. dot, this dot, this dot, this dot. All right, and I'm actually going to put the ellipse functions here inside display. All right, and we need this dot again. And actually, I'm not gonna draw the center anymore. And then we don't need the line either. All right, how about we actually fill it with color white and then do no stroke. And inside sketch here, we're gonna give the background the color black. All right, let's create just one dot. So how about we declare a variable called d, and d is going to be a new dot object at location 150 by 150. Then we're going to update it, and then we're gonna display. All right, let's try this. Ooh, are either undefined or not a finite number. All right, let's see, what did I do wrong in here? I forgot to give it one more argument. So start with 0. All right, so now it's just moving back and forth. Perfect. So why don't we make a bunch of dots inside a grid? So I'm going to create an array called dots, and then we're going to create a few more variables called calls, rows, and then how about we set size to be 10. And then inside setup, what we're going to do is that we're going to first calculate columns and rows. So it's going to be columns equals to width divided by size, and then rows is going to be equals to height divided by size. And then now this dots array is going to be a 2D array, and so I'm going to use a nested loop. So for let I equals to 0, I less than calls, I plus plus. For let j equals to 0, j less than rows, and then j plus plus. One of these days, I'm going to use a new syntax, but today, let's go with this. So inside this outer loop, we're going to populate the dots array with a bunch of empty arrays, and then inside the inner loop, we're going to populate the inner array with new dots objects, right? And what should be the x and y location? So we want to space them out evenly, right? So it's going to be x equals to I times size, and then y equals to j times size. All right, and then we're going to just copy these nested loop, and then we're going to, oops, actually delete this, and then we're gonna call the update and the display function. All right. Whoa. Okay, something's working, but let's go back to the class again. I'm actually going to comment this angle increment, and how about we actually make the size of the dots a little bit smaller. Okay, can you see that it's a little bit to the left? It's not center in the middle. So actually it would be easier to see if I change this to size 20. Maybe a little bit. Basically, we need to offset it by size divided by 2 for both x and y. All right, so now it's center, and I can uncomment this. All right, it's going really fast. Actually, I'm going to set this as a variable called speed. So this dot speed will be equal to speed. All right. And actually, before we go, I'm going to actually give it another parameter called scale. And basically, scale is going to be multiplied to this. Actually, I can just do this. CL maybe. Basically, I want to be able to scale the maximum magnitude. And okay, so when we go back here, how about we set the speed to be a little bit slower at 0.05, and then let's set scale to 1 for now. And then we need to put here as speed and scale. All right, still kind of fast. Let's do this. All right. Okay, but you're not seeing the wavy pattern, and that is because of this starting angle that we give it at 0. So we actually want to vary this based on where each of these dots are on the canvas. What we need to do is that we need to calculate the distance between each of the dots and the center. So I'm going to declare a variable called distance, and I'm going to find a distance between the dot and the center, and I can use a function called dist between x and y and the center, right? So it's going to be width divided by 2 and then height divided by 2. And then I actually want to map it to the angle, and I'm going to map it between 0 and 2 pi, which is 1 revolution, right? So how about we do angle equals to map of the value distance between 0 and width divided by 2. So width divided by 2 is not actually the highest or like the biggest length, right? Because if you're the top left corner or the corner dots, the distance is actually a little bit bigger than that, but you can map it to whatever you want. And you'll see that if you vary these variables, they are going to actually create different kind of pattern. But now I'm going to actually just map the distance value here, variable between 0 and width divided by 2, and map it to values of 0 and 2 pi. And then now, instead of putting in 0 here, let's put in angle. Let's see what happens. Whoa. That's pretty cool. That's pretty cool. All right, so actually I want to, let's bring it back to 10. And then I want to give it a little bit of a margin. So how about we declare margin to be 30. So the cols and rows calculation here has to be width minus margin times 2, and then height minus margin times 2. All right, you can't really tell here, but it is a little bit to the left, so we actually need to also add margin to x and y here to make sure that everything is centered. Okay, all right, so the reason that it seems like it's so big right now is because the maximum magnitude is between the point and the center, right? So now that's where this scaling variable comes into play. So instead of 1, what if we do 0.1? All right, let's make it a little bit faster. It's pretty neat, right? It looks like it's just one wave that is going back and forth. Then now you can play with the different variables. So instead of 2 pi here, what if you do more than 1 revolution of a circle? So how about I multiply it by 2? Then now what do you see? You see 2 waves, right? And you can increase this to 2.5. It doesn't have to be a whole number. You can do 3. All right. And what if instead of doing a constant scale of 0.1, what if you also actually map it to the distance, right? We can do that too. So let scales be equals to map of distance between 0 and width divided by 2. And how about we give it such that the dots that are further away will be moving slightly, have a scale of a smaller scale. So let's do, how about 0. What do I have it right now? I don't know. So let's do, how about 0.03 and 0.01. Maybe that's very small. Let's see. Wow. Okay, let's do a little bit bigger. Let's do 0.1 and 0.05. I actually kind of like the more subtle look, so let's do this. You can play around with all of these different variables. And let me show you, why don't we do 5? Whoa. And then how about I change the size here to smaller. All right, and then the last thing that I want to show you is actually, what if I give it the background a little bit of a transparency. So if I do 30, meaning that every time you draw the background, it's not opaque, basically. So let's try that. I wonder if you can tell. You can see a little bit of, if I decrease this value to 10, can you see the trail? That's pretty neat, right? All right, so as you can see, there is so many different variables that you can play around to get a different look, but this should give you a basic foundation of how to create these oscillating circular waves. So I hope that you enjoyed this one and give it a try.